All right, I think the recording had already started. So I'll filter out everything before I post to YouTube later on tonight. But this is the April 30th, 2026 Crossplane community meeting. Let me go ahead and drop a link to the agenda document in the chat so that folks can pop in there if they're not and add anything to the agenda that they wish to talk about. So let's start rolling. First, talk about previous releases. So over the last week or so, pretty darn recently, I think, we did a series of patch releases for all currently supported versions of Crossplane, which normally we run 3 versions, but right now we're still supporting the last V1 version, 1.20, with any critical fixes. So we did a whole bunch of CVE patching, basically. We're a little behind on that, arguably. So we picked up a bunch of updates on all of our dependencies and then backported a couple of fixes as well. One of the more notable ones is that there was a bug preventing composition functions. If you're specifying required resources from your composition function, if you didn't specify anything, you just specified a particular kind, then it would not get anything at all, as opposed to giving all the resources of that. So that now works as expected and as was documented, just not working correctly. So the latest patch releases through all the V2 ones, I think, got picked up that fix. So we got 2.2.1, 2.1.5, 2.0.8, and then 1.20 got 2 because we missed a dependency. So 1.20.7 picked up that last CVE fix, I think. I don't know of any pending plans for more patch releases before we get to the 2.3 release, where we'll do a round of releases then as well. So we're coming up soon on the schedule for that. So there's a link in here to folks to get to the community calendar and follow along there as always. But right here in the agenda doc, we've got May 5th which is next week, is the planned feature freeze. And then a week after that would be the code freeze with a release candidate build being published for people to test, which has historically been super helpful when folks test that and make sure that there's no critical blocking issues. And then May 19th would be release day. So over the next couple of weeks, we'll expect to see 2.3 rolled out. As always, that's tentative. So we'll see what the burn down looks like on the release for any critical blockers, if anything comes up that we really need to address. But this is the planned schedule as of now. There's a couple of things that I really want us to get finished. There's a bunch of things that have already been handled. Like for instance, cross-plane state metrics that exists. That's all happy and good. The provider deletion protection, I really want to get that in for 2.3, and we just took a pass through that this morning. Was that this morning or yesterday? Very recently, either way. That Christopher Haar had put together a PR. I think we want to try to explore a slightly different approach that reuses basically the usage deletion protection objects in a more automated way. So I'll check in with Christopher and see if that's going to be possible for 2.3, but I'm still viewing this as a really important feature that is overdue, basically, and I really want to get this in the 2.3 release. Bob, I hope you saw you're already talking with Lovro that the management policy enhancements that you had proposed. Lovro kind of took a pass through and maybe gave I think he gave a little bit of design input on that one. So hopefully you'll have the time on your side to maybe look at that and incorporate that too.
Yeah, I saw that. And yes, hopefully.
We'll leave it at hope.
Yeah, I mean, so that's what weekends are for, right?
Yes, that's one thing that weekends are for. My weekend here is going to be traveling back to California. So that's definitely my important thing, is going back home after being away for a couple of months. But you enjoy your weekend, Bob. You do what you should do.
Well, it sounds like you're gonna have a ton of time on the plane, so
Oh yeah, which is a very productive place to work. We don't care about you, coach. All right. Let's quickly look at the board. I don't think it's super cleaned, but let me just quickly bring it up to see if there's anything that folks really wanted to bring up. I'll need to take a pass through to kind of catch things up on here, but there's a lot of stuff that's still in flight. Plenty of things being reviewed. Lots of stuff already done. Does anybody have anything they wanted to bring up for 2.3? Alrighty. Let's keep on moving then. Prove that. So yeah, cool. Let's talk about ecosystem stuff. So we have going through just the various releases of providers and functions and stuff. And if you have one, please go ahead and add it to the list here. But one thing I noticed is, Jesus, are you on the call today? You are here often, but maybe not today. Oh, you are. I think so. Yes. So yeah, Jay Fernandez has done a bunch of awesome work on providers and getting new releases out and reviving providers that other maintainers have neglected. So special thanks to you for getting a bunch of providers with some velocity there. And then okay, and then a whole bunch of CVEs across a bunch of providers and functions. Those aren't linked, and I'm not going to look them up anyways, but it's good to see that CVEs are getting fixed in core Crossplane and across the ecosystem as well, and some more automation has been built around that too. So that's very nice to see the progress on that to continue to try to keep all these artifacts in the Crossplane ecosystem in a nice, healthy state. All right, so let's just check in on some of the investments being made in the across the ecosystem as well. Folks can check the details of these notes and to try to dive down into more of them. But I'm hoping that we see some build time improvements. I know folks love waiting on big providers to be built, so hopefully we're going to see some improvements with some caching mechanisms being added recently. And then I think like in the context of some of the API lifecycle stuff, I believe it was, adding some new testing there for making sure that sort of the quality and reliability of the APIs being able to round trip successfully is something that providers built from the upjet tooling will be able to pick up soon as well. That's mostly it. And folks can check in on this one as well, to see if they're impacted by that one and can pick up that fix as well. Any other ecosystem stuff, functions, providers, extensions? Jean, did you want to mention anything from your latest release on Crossplane Diff?
So the big thing from the last couple of releases from Diff is that we now have machine readable output for all of the modes. So super helpful for like running in CI or whatever. Inside my org, the person that's in charge of the bots and stuff likes to sort of render it himself. So that was useful for us in CI. Otherwise, just lots of bug fixes. Should be working better.
Awesome. And John, thanks for the feedback that you're giving to Adam as well on like the render update to use the new internal render commands. I know that was very valuable.
Yeah, no problem.
Cool. Okay. Let's keep on trucking then, so we have plenty of time for our speakers. Adam, let's go ahead and get a quick catch up from you on some of the SIG CLI progress.
Yeah, so I'll actually start with maybe the second one there.
Okay.
So this is a big change that we have in review. Nick implemented this Crossplane internal render command that actually reuses the real reconciler. So we don't need to duplicate it in the CLI render anymore. So I've got to change up to actually use that. And that is the last thing we need to do before we can move the crank command and its code into the new Crossplane/CLI repository and separate it from Crossplane, which is the plan. So I'm hoping we'll get that done in the next week or so, and then we will start adding the actual DevX stuff that we've been talking about for months and months and demoed at KubeCon and all that stuff. So we'll be there pretty quick. And that kind of leads to the other topic there, which is as we are separating out the CLI into its own repository. We need to decide how we want to version it and how and when it gets released. One of the big reasons to move it into its own repository is so that it can move faster than the core of Crossplane, because it is a different kind of software. I think it makes sense that it can release faster. So that's the hope, is that we can decouple the release process, but we do need to make some decisions about versioning and compatibility and how we manage that, since it is still Crossplane related, even if it's not part of the same project. So yeah, this is up for review, open to feedback here, but it's something that we should decide, at least the short-term plan, in the next couple of weeks.
Yeah, it looks like it's gotten a bit of traction for folks weighing in, like Theo and Chris and such. So that's good. Folks got some eyes on it.
I'll catch up on the comments today. I haven't read through them yet, but yeah, thanks for taking a look.
Well, you've got some gifts waiting for you then, my friend.
Yeah.
And then Adam, you could also catch up on my early comments then on the CLI update too.
Yeah, haven't taken a look yet today, but I will get to that for sure.
Cool. And I have more to review on that. That was just some early questions as I was diving into it. So I'll follow up to get more on that too, my friend. Okay, cool. Awesome. Then one thing I wanted to remind folks here is that this is not from the perspective of like, hey, folks at this meeting, you need to follow the code of conduct, because everybody here is pretty awesome. You all are great contributors to the community and doing amazing work. This is more of a reminder of there are more people contributing to more projects nowadays. Some of them do not have the best behavior, as more folks get access to AI tools and stuff and contributing to things they haven't contributed to perhaps in the past. We had a recent incident where someone was contributing something malicious and they're violating GitHub's terms of use, basically, with some of the things they were doing and the way they were engaging on PRs. So this is not a call to tell you people to behave, because you're amazing people and you do behave. But if you do, like, we have a broad ecosystem and a lot of projects. And so, one person or one steering committee, and it can't necessarily watch everything. So if there are any conduct issues, abuse, harassment, any sort of stuff like that, please do feel free to reach out to the steering committee immediately. And so we can help moderate that. I think maintainers have permissions on their repos to moderate themselves as well. So do feel empowered to take appropriate actions to work within the CNCF's code of conduct, and obviously GitHub's community guidelines as well. To ban users or remove content or whatever necessary. But if you need help, absolutely reach out to the steering committee or even just DM me personally, and I'll be happy to jump in to help out and make sure that the community is healthy and acting as great as everyone in this call does. Cool. Next quick thing before we move to our speakers is that I opened up a proposal issue here that I think will be useful. I've heard from a few people that it would be useful. Is that one problem with folks wanting to go to V2 is that they don't know if it's safe for them to. We did a lot of work to have a ton of things have backward compatibility in V2, but there are a couple of things that we took the opportunity to remove, mostly things that were long deprecated, long overdue features to remove. So but there's not necessarily an easy way for folks to gain confidence that their control plane is ready to go to V2 without any hiccups. So this proposal issue is around having basically a CLI command that targets 1.20, because that's where you need it. You don't need it in 2.0 or 2.x. That basically looks at your cluster or your control plane and tells you everything that is not safe for V2. I did a POC on it and it seems to work pretty well. So this may be something that moves kind of quickly, but I wanted to call it out for folks to either, drop some feedback on here if you think this would be useful, if you think of other scenarios that it should be checking for, any sort of feedback, go ahead and leave some comments on this to make sure that this would be going in the right direction, to help people be able to give some confidence that they are ready to upgrade to V2.
I'd be interested to hear from someone who's actually done an in-place migration from V1 to V2 and what that experience is like. I in my company started the deployment like right around that boundary, so most of my experience has been deploying into V2 directly. But it was my understanding, based on like the little bit of V1 stuff that I had deployed before that it's not an easy upgrade. That there might be some duplication and re-importing and things like that, right? Um, I don't know
So
if that's correct or not.
yeah, I think something really important to call out there, John, is that there's a big difference between, okay, cool, I've got like, you know, claims and XRs and stuff in V1 that are not using any of the removed features, you know, like native, classic, patch and transform, you know, not using functions at all type of thing, or using controller config, that kind of stuff. There's a big difference between, cool, my control plane isn't using any of this stuff. I upgrade and everything works just as it did before because claims are still supported, you know, in V2. So that should have no, you should have to do nothing at all. It should be super easy upgrade. Everything works and everything's happy. The where it gets much more tricky, as what you're alluding to there, is that if you want to take your existing live resources and migrate them from cluster scope to namespace scope and all that, yes, that is very challenging. There's some things to watch out for there. There's some ways to address that over the future, but like the base case of, cool, you're not using broken features, you can go to V2 and start getting, you know, new updates and start doing greenfield, new resources and namespace scope and all that sort of stuff. That I hope to be very easy. If that has it problems, then that's something that we need to be aware of, because I don't know of any big blockers on that path.
Yeah, I can attest to that actually. Um, we did the migration on our side from like V1 to V2, just the crossplane itself, and everything went fine. We still haven't migrated our compositions to the new features sets, and we do want to do that, but it's like, as you said, it's very tricky, and uh, we wanted to do it in place, but then yeah, you need to like orphan everything and make sure that whatever's going to get recreated is actually idempotent, so it's not going to like create new stuff. So
And
yeah,
then moving from the .m to or moving from the cluster scope to like the .m
yeah.
version of the, yeah.
Yeah, you need to update your functions and everything that generates resources. It's a big work, and we still haven't planned it because of how big it is.
Yeah, and I wonder if there's something that we can do to lubricate that process, some manner of like a transformation tool or something like that. I mean, even something in the you know, in the controller, to help, you know, ease that migration forward. Like, hey, this thing is compatible between V1 and V2. I don't want to have to orphan it and then re-import it in a new version. Maybe there's something we can do to help with that. I don't know exactly what, but I think
Yeah,
we should be thinking about it.
Yeah,
I agree. I would love that.
I think the main problem is that it's it's an API group change and possibly an API version change, um, which in Kubernetes is by definition, a new object. Um, so
Yeah, but it,
unless somebody else has figured a way to do it, right? There's no way today to change an existing Kubernetes resource, change the API group on an existing Kubernetes resource.
Yeah, so I mean, I think you can probably do it procedurally. I don't think it's going to be exactly the same object. Um, but there should be a procedural way to say, okay, I'm gonna create this new set of objects, this V2 set of objects in observe only mode, right? And then I'm going to retire the old ones, and then I'm going to flip from observe to manage mode. And I think something in the controller, or maybe in a CLI tool or whatever, should be able to perform some of that work for us, right? If we can figure out what the state machine looks like.
Yeah, I think there is definitely some demand for folks that do want to migrate their live resources to, you know, to namespace ones. Essentially, there is demand for that, and I'd like to see some. There's been some progress in various different folks making progress on that. So having something more unified or having a more clear, consolidated guidance, I think is going to be an investment to make. Let's
Jared,
get
should we like set up a SIG for this? Because I think there's a lot of different streams going on, and maybe we just have a single place to collect it.
Yeah, that's not a bad idea, Stephen, to have some like a shared brain trust around that. That's not a bad idea, Stephen.
Yeah.
Do you wanna like take a note on that or post on that somewhere so we can follow up on that?
Yeah.
Cool. Thanks for that, Stephen. All right, so let's keep moving forward, because we've got 2 speakers here, and I'm going to give them plenty of time. So we've got 35 minutes left right now. I think Tim said that he needs 15 to 20, and then Yuan needs 10. So with questions and stuff like that, I think we should be good. So I'll stop sharing now. And Tim, it's your turn first.
Awesome. Thanks so much. Yeah, I'll try and go quickly. Okay. You can see my screen here. See the slides.
Yep, I can see that.
Cool. All right. Well, Jared, thank you so much for having me. Everyone, my name's Tim. I'm a PhD student and a software engineer currently at UC Santa Cruz. And I'm going to be talking today about a new tool I've been developing called Camera that seeks to make it way easier to test custom control planes like Crossplane using simulation. So I have some intro, but I'll go kind of quick because I think most people here are pretty familiar with the Kubernetes control plane. But essentially, the motivation behind Camera is there's this modular architecture. If you want to add some new feature to your platform, you just create a new resource and a dedicated controller to manage that resource. And of course, we can compose resources into higher level abstractions and drive that composition with more controllers. And of course, Crossplane, makes heavy use of this pattern. We have compositions and composition controllers, etc. So it's a powerful programming model, but it's pretty hard to use. For one, just writing a given controller by itself can be pretty tricky. You need to express this business logic in terms of this control loop that needs to be idempotent. And when you're building control planes that involve multiple controllers, now you need to reason about potential race conditions between their operations or pathological ways of them interacting that might produce update cycles and things that prevent the system from stabilizing. And debugging these types of issues today is not a great experience. You can go into the pod logs for your controller and sift through those and then do the same for another controller, but it's still pretty hard to reason about how one controller's actions affect some other controller, or more broadly, how everything interacts given that the system is loosely coupled and asynchronous. And for multi-controller reconciliation flows, the testing experience isn't super great today either. It typically involves some end-to-end system test. Kind is great for this, but just to test some business logic spanning multiple controllers, having to spin up an actual local Kubernetes cluster, get the containers running, etc. It's pretty heavy and it's pretty slow. So that's the main motivation behind this new tool that I'm building called Camera, which seeks to make it a lot easier to test multi-controller flows or to test custom control planes. And it's going to do that using simulation. So going back to this hand-drawn diagram of the control plane that I have here, the core idea that Camera is exploiting is the fact that controllers all communicate with the cluster using the same access pattern, namely an API server client. So the insight that Camera makes is if we just replace the API server with a simulated version and expose something that looks like the API server client controllers already use, then we can create a simulation framework without modifying the actual controller code that we're testing. So that's what Camera is in a nutshell. It's going to simulate the rest of the cluster, but preserve the actual controller code in your control plane. And it's going to be able to drive reconciliation scenarios all within one process. And I've built Camera targeting controller runtime, so controllers that are built using the controller runtime framework can be wired up to Camera without any code changes, which is a pretty nice property to have. Okay, so this is the overall architectural kind of summary of how Camera works. I'll now talk about how the simulation part actually works. So to start explaining that, we can just consider the cluster as a state transition system, where a controller reconcile is going to transition from one state to another state. And within each reconcile invocation, a controller performs some series of API operations that change the cluster state. So some controller might be creating a replica set. When this happens, we also know that the replica set controller is going to be triggered by that state change to reconcile this new replica set. So there's this notion of pending reconciles in response to a state transition. And Camera is going to incorporate that notion of pending reconciles into how it models the state of a simulation at any given point in time. So the simulation state is both the cluster contents, like the stuff in etcd, as well as the set of controllers that are pending reconciliation from that transition into that resource state. So that's the like cluster state representation in the simulated domain. With this in mind, I'll now illustrate how we use that to drive simulations. So let's consider some simple scenario where a user has just created a deployment. Our cluster is in state S. We have this new deployment in this cluster contents. And we know that the deployment controller, which I'm representing here as CD, has been triggered and is going to reconcile this new deployment. So camera is going to go into the pending reconciles set of this cluster state. It's going to select an element, the deployment controller in this case, and it's going to invoke the deployment controller's reconciled routine on the contents of S. So it's going to see this deployment D, and then it's going to create a replica set for that deployment. And we're going to enter a new state, S prime, where that new replica set is now in the cluster's contents. And we've also added the replica set controller to this new state's pending reconciles set based on the like subscription rules for which controllers, watch which resources and have the reconciliation routines triggered. And the deployment controller is probably also going to update some status about the deployment to reflect that the replica set for it has been created. So the deployment controller is going to also enter back into that pending reconciles set. And then this process repeats, taking the next step. The simulator is going to pick another controller out of this pending reconcile set. Say the deployment controller is selected again. In this case, it's not going to do anything. It's going to see, oh, there's already a replica set in the simulated state, and the deployment's status already reflects that the replica set exists. So it's going to perform a no-op reconcile. And the simulation is going to transition into a new state, which has the same resource contents as the state prior, but a different pending reconciles set. So camera treats those as two distinct things. And then this process continues. The replica set controller is going to go, it's going to create a pod. That pod is going to get scheduled. More simulation steps will unfold. The pod is going to become running. Status is going to propagate back up through the replica set to the deployment, and we're eventually going to stop. What happens when we stop? Well, it means that we've converged. And the way that we represent convergence in simulation is a state that has an empty pending reconciles set. So this means that every controller that had some role or stake in the reconciliation process got a chance to see the cluster state, decide that, okay, everything looks good, I don't need to do anything. And that becomes true for all controllers in the system. So this is how we represent convergence in camera simulations. Of course, convergence is what we hope happens, but it might not happen. What if this keeps going indefinitely? Perhaps there's some non-idempotent business logic somewhere in one of our controllers, or maybe two controllers are thrashing, fighting over some resource attribute, and the system isn't stabilizing. In real Kubernetes, this can put a lot of strain on the API server, potentially to the point of destabilizing it. So it's very useful to be able to catch these types of scenarios in simulation. And in addition to non-convergence situations, we also want to be able to reason about non-deterministic convergence. So I'll step back here a little bit. You may have noticed that earlier in my example, I kind of arbitrarily picked that the deployment controller is going to go next. But in actual Kubernetes, there's no notion of who goes next or what order things happen in. It's totally arbitrary, not enforced by the system. And we can envision a parallel execution branch where instead the replica set controller would go next at this step. So that looks like some parallel branch that then unfolds similarly until the state converges again. Okay, so now we have these two converged states in our simulation. Well, if the resource contents of those states are the same, that's totally fine. It just means that there were multiple paths to convergence, and in a fully asynchronous and loosely coupled system like Kubernetes, we should expect to see these types of things all the time. But if the resource contents are different, that might indicate a problem. In other words, somewhere along the way in the reconciliation process, there was some sensitivity to the order of operations. In other words, a race condition. So that's probably something that we don't want and would like to be able to catch. So the simulator can explore, multiple orderings of who goes next when there are multiple options in this pending reconcile set. And more broadly, these simulation capabilities enable a style of testing called model checking, where when you have some execution model of the possible, space of executions in your system, you can then search that space exhaustively to try and verify properties that you care about. So in the Kubernetes case, we probably care about the property that our system converges, and it does so deterministically, no matter the runtime variations. And we can do that by exploring exhaustively every ordering, track which converged states we see along the way, and compare them. And we can do so up to some maximum depth that we configure. So in the happy path where there are no bugs, the sort of visual representation of this graph that we're searching will sort of look like something like this, where from some start state, we might fan out into a bunch of intermediate states, but we eventually arrive at the same place. But in case of some race condition somewhere, there's going to be a divergence where we non-deterministically arrive at a different end state, depending on something that happened along the way. And then in the case of some update cycle or some non-convergence condition, that'll look like a path that just goes for a long time until it hits some like maximum depth parameter that we tune, and we just say like, if it hasn't converged by this point, there's probably something wrong. And this brings me to the first bug that I found in Crossplane. So I wired Crossplane's controllers up to camera. And the first thing that I noticed was that there were a couple of places in the code base where there's an unconditional status update in the reconcile logic. So in each invocation of the reconcile routine, there's a write to the API server. And in my simulator, this will fail. This will show that you don't converge. The system never enters a quiescent state. So I have a quick demo of what this looks like. The simulator tool that I'm building comes with a terminal interface. So let me just boot up a quick demo. Sorry, one sec. This scenario I'm testing is when a user has just applied a composition and there's already a function installed into the system, and the system is bootstrapping up a composition revision. And you can see that because the composition revision reconciler is always updating status on every reconcile, we get this, I guess you could call it thrashing, where the simulation or the reconciliation process never converges. And then I can apply a code change to the reconciler routine where I'm essentially just checking, did the status actually change? If so, update the status via the API. Otherwise, don't. And I can show you what that looks like in the simulation after I apply the fix. Much better. Okay, we can see that the composition revision reconciler is reconciling, and then we eventually get to some final end state that is stable. So that is one pattern of bug. I found a few more. I can give a quick overview. One of the bugs that I uncovered poking around using camera was that you can, there's a missing validation step where I think a composition revision, an XR can point to a composition revision ref and also point to a composition that is unrelated to the composition revision, if that makes sense. There's another one that's an open issue where I think this is like a missing finalizer where you can delete a composition that still has XRs bound to it, and then these things will just enter this permanent error loop. Both of these were reproducible on a kind cluster. And then some of the race condition type bugs are much harder to reproduce on an actual kind cluster because you don't have control to the timing conditions, in that environment. But in simulation, I found some cases largely around status condition semantics and catching them in inconsistent states depending on the order of updates. One of them, I think on composition revisions, there's a race where the valid pipeline condition can be true after a function revision change, which would, like, it should be false, but it's still true, essentially. And then on composite resources, there's a case that I uncovered where the resource can enter the state where ready remains true, even though there's some error and synced is false. So there's like an inconsistency there. These are open on GitHub. I'm still, I'm not a Crossplane expert by any means. So there's some of these, these still need feedback, from the community. But yeah, that's a high level overview of Camera. It's been developed as a research prototype, but it needs help from the community to get it into like a beta version at least. I want people to use it to make their lives easier, hopefully. But if you could please just like give it a star on GitHub, get it some more visibility, share it with your colleagues, or try it out. That would mean so much to me. So that concludes my presentation. Thank you so much for your time.
Yeah, right on, Tim. That was really cool. And I before you started talking and like sharing the details of it, Tim, well, I definitely expected to not understand any of the details of how it works, but that was excellently described and kind of explained of like, here's the states it looks at, here kind of how it runs the simulation, here's some of the how it finds issues, like when the state isn't converging or non-deterministic fashion there. Like I actually understand what you're talking about there, and I'm very pleased with not my own intelligence definitely, but your explanation of it.
Oh, thank you so much.
Yes. And then you have an open PR, right, to fix that, like the status thrashing update one, right? You opened a PR to fix that?
I think it's
cool.
In flight. Yeah.
Yep. Yeah, I want to get that one in for 2.3 as well. That would be great to get that one merged. So we need to follow up on that. Do other folks have questions on this and how it could be? We could probably use this for other controllers outside of Crossplane too, then, Tim, like for other providers and other things of the Crossplane ecosystem.
Yeah, exactly. That was another note I wanted to say is this was my first stab at testing Crossplane with this tool, but it's by no means done. There's a lot more work to do, and I could use some pointers definitely from the community on where to best apply this type of testing.
Amazing.
I had a question about the UI that you showed. Is that part of Camera, like the terminal UI?
It is, yeah.
Okay, awesome. Yeah, it looks super useful.
Just a little like utility that I included. But yeah, the kind of, it's sort of trying to like provide a stepwise debugging thing where like given some simulation, you can go and inspect like, okay, what exactly changed? What was the before state? What was the after state, etc.
Yeah, cool.
Awesome. All right, cool. So yeah, if there's no more questions, then we'll keep on going through the agenda here. Johan, you're next if you want to take it away.
Yep. Let me share my screen. All right. All right. You can see my screen. So I'm Johan from Elastic, and we are using Crossplane to deploy Kubernetes cluster mainly, but like trying to manage infrastructure in general. And as part of in my team, I wanted to like do a POC to see if it was feasible to create a provider that was implementing data sources. So like, as you probably all know, currently Crossplane provider, they only support creating and managing like a real resource, like the equivalent to Terraform resource block, but they lack the ability to query the state of the infrastructure at the CSP level. like basically use the data blocks of Terraform. Like the following example, for example, it's not really possible to implement currently with the provider that exists. So what we did for now at Elastic was to like use environment config and put stuff in, or inside claims to like describe the infrastructure, because like we have an infrastructure that is built partly with Crossplane and partly with Terraform. So we need like to bridge the two systems together. And as part of that, what we currently do is like we add some information in our claims or in environment config to teach the Crossplane layer to find what already exists in the infrastructure. So what I did basically is I tried to create a data provider. So based on the same library that that object used to generate the provider. And what I did like is that I changed the code that queries Terraform. So instead of like calling the Terraform stack that creates and update resources, I queried the APIs that can retrieve data that is the underlying code that Terraform provide to fill data sources. So it, like every other provider, it exposed the Terraform data source as Kubernetes CRD. We could say manage resource somehow. I've suffixed the CRD with the data in order to make that easier to distinguish between the resource that are data sources and regular resources, and like it provides the same capability, filtering capability as Terraform. That's pretty much it for the introduction. Let's go to the demo. It's going to be more interesting. Okay, so let me share what the code looks like. So basically, what I did is like I kind of did what Object would do to create a provider, and I did it myself. So I created a skeleton provider and like put all the stuff that Object would do. And then I have added I added code to talk to the Terraform API that fetch data. So one thing that I didn't do is to change Object to generate the CRDs for data sources. So I used an LLM to create the CRD schemas. So the LLM was looking at the Terraform structure, the Terraform data model, and then was outputting the CRD. So this is something that is automated with objects in real providers, but for like the POC was good enough. And then using that that data model, generate a CRD that can then be used to query the data sources. So if I take an example, let's go to an example. For example, here we have an XR, an M. I don't know how to call them because like it's an MR, but it's not managing a resource. We could call it a DR maybe. So it's a CRD to fetch AMI data. So I followed like the same principle as other providers. So it used a for provider to fill the data for connecting to the provider, finding the provider config, and like setting the filter of the data source, like you would do in Terraform. And if you apply that in a cluster, so I'm here, I'm going to apply that in my test cluster. So I got like, I have 4 AMI data custom resource in this file. I get a data source that is reconciled like any other resource. So if we look at this one, for example, we have the filters that are passed to the Terraform provider, and then under status at provider, we have the field that we would have in the data source in Terraform. So in terms of what we implemented, like it was just a POC, we implemented like the resources that we need internally. So it's definitely not like production grade, as like it's an LLM that generates the schema. But I was able to make that work for some common resources that we need to look up in our infrastructure, like for example, subnet or VPC. So let's say we want, for example, to query what are the VPC, what are the available VPC in, let's go here, no, in the example folder. What are the number of VPC and what are the available VPC in an account, for example, and then we apply this CRD, and then we can get the list of available VPC. Hopefully, it gets reconciled. You get the list of VPC that exist, and then if you want to have detail on the VPC, you can either pass the ID of the VPC or like use a filtering like this, for example. So it's pretty common for people to like name their resources to be able to look them up in other composition or other part of the infrastructure. So if we, for example, apply this one, we'll get, so not sure I'm fast enough to, yeah, it's not yet synced. That's good. Shows that I am not cheating. It's actually doing things. Okay, so actually, I guess there is no core VPC on this one. So if we look at this, it doesn't reconcile properly. Okay, so there is more than one VPC actually in this account now that has this name. So the reconciliation doesn't work. Okay. So how does that work basically? So we have like this CRD here that is generated from the API definition, like the model here, and then compared to an object provider, what changed basically is this package that implements the Terraform plugin SDK external in a way that can query data sources. So I mean, there is no any like black magic here, as it was just like to verify that it was possible to implement that. Right. So in terms of where we are with this POC, so like I said earlier, it for now the generation of the schema was done by an LLM just for POC. So if we want to make that production ready, we would have to update object to generate the schema. I used the V2 runtime, but I only implemented clustered scope resources and not namespace scope resources because like it was just a lot of copy and paste, and there was no reason to do that, just to prove that things could work. Also, we would need to add support for Terraform framework style APIs. So far, the data source provider only support Terraform plugin SDK v2 style data source. And I guess we would need also to discuss with the Crossplane community and how we want to expose data source. Is this way of doing data source provider the right way, or how would happen with the explosion of the CRD count because there is a lot of data source available in some providers. And I'm done with the demo, I think. Ready for questions?
Yeah. How different is this from just creating a managed resource with an observe only policy?
So with the observe only policy, you cannot use, for example, if you want to look up a VPC, going back to my example here, if you want to look up a VPC, you cannot use the filtering here. You cannot say, give me all the VPCs that match this query. You can only look up the VPC if you already know the VPC ID identifier in the AWS. So if you want to do some discovery, like, I don't know, for example, the AMI example here, if you want to find the AMI, you need to know the AMI ID already in order to be able to create a managed resource that get you the information of the AMI. As with here, you have the ability to query basically the CSP infrastructure.
I mean, I guess I wonder, so you're getting a lot of mileage out of Upjet here, so I understand that you're kind of just generating these based on the data sources that are existent in the Terraform providers. But I wonder if some facility on the corresponding MRs would be useful for this sort of like lookup without having to like create basically a second CRD for every resource type.
So the thing is, like in the Terraform code, the definition between the data source and a resource block, they are different. Sometimes you don't have the same field and so on. So in order to really map what is available at the Terraform provider level, we need to have like two distinct CRD, unfortunately. If you want to, because like for example, the filter field in the input, it doesn't exist on the resource block. It only exists on the data source block. Yes, Krishnan?
So I think there are two use cases here as well. One is that you might want to observe a singular resource that you want to import, like that you created in Terraform. The second use case that you might actually want to look up a list of resources and get a bunch of VPCs and do something with them. I don't know what, but so one use case is the one-to-one mapping that we all know and love in Crossplane. The other use case is actually like a lookup that gives you multiple records.
Yeah, one use case like you mentioned is like to be able to like easily migrate from Terraform to Crossplane. Also, if like the Crossplane side is able to auto-discover what is existing already in the infrastructure, it makes it much easier to like write a migration path from infrastructure that is managed in Terraform to infrastructure that is managed by Crossplane. Otherwise, we have to like write an import spec with all the IDs of everything, and it can be complicated. Any other questions?
Cool.
Right.
Yeah, and thank you very much for showing this off, Johan. I think that it's compelling, clearly, because there's been kind of a missing need in like the way you were describing the like problem you all had that kind of led you to start prototyping and exploring this is definitely something that folks have run into for a long time, right? Of like, oh, I have to know the exact ID or name of this thing in order to import it into and be able to use it easily. That's like it's been a limitation for a long time, and I think this is very much speaking to that need. So like this exploration into this, like is really quite appreciated. And yeah, if you want to sort of take any next steps to kind of propose the general direction here, and so community can weigh in on it and stuff, and kind of rally around a particular architecture or consolidation there, then yeah, that would be great. But like thank you for your efforts so far, for sure.
Thanks.
Cool. Okay, well, that's all the agenda we had, and we're just about out of time. So excellent time management on everyone's part here. Thank you very much to Tim and to Jan for showing off really cool stuff that they're building. And then I think the next time we see each other, we will hopefully have the 2.3 release out by then, I think. So yeah, thanks for everybody being here today, and good to see all of you.
Thank you.
Sweet.
Take care.
Thank you.
Thank you.